Question number 1, part A, show that A equals a quarter. So these two pieces of information gave me those two brackets, so I need to use this piece of information. So 4 equals A times 0 plus 2 squared times 0 minus 2 squared. 4 equals 16A, A equals 1/4. Done. Part B, express this in that form. So I'm going to type it over here. I've got 1 divided by 4 bracket x plus 2 squared bracket x minus 2 squared. Execute. I'm going to take that, interactive transform, expand, and it gives me, so f of x equals x to the 4 on 4 minus 2x squared plus 4, therefore b equals 2 and c equals 4, b equals -2. Okay, that's part B. Part C, part of the graph of the derivative is shown. So this is the graph of the derivative. Write a rule for the derivative. Okay, so I've got this, and I'm going to take its derivative, and that gives me x cubed minus 4x. Find the minimum value of the derivative from 0 to 2. So I'm going to take this, and I'm going to go interactive calculation, f min from 0 to 2. Okay, and that gives me -16 root 3 on 9. So minimum equals -16 root 3 on 9. F min of x cubed minus 4x from 0 to 2. There's my method mark, there's my answer mark. Find a sequence of 2 transformations that maps the graph. So there's 2 particular answers you can do. I'm going of f onto h. I'm going from f and I'm going to h. I could, did you find out what? And this is h. It's been moved up to, and there's a negative at the front. So I reflect over the x-axis and translate up 2 units. We'll do it. Or you could translate down 2 units and reflect over the x-axis, and that would also give it, you only need one of the answers though. State the values of x for which the graphs of f and x intersect. Okay, so I've got this curve, which is beautiful, and then I've got that curve where I put a bracket around it, make it negative, and then +2. And if I graph that, that's exactly what we're looking for. So I'm going to have my original equals to this, and I'm going to interactive event solve. There are only 4 answers, so I don't need to put a restricted domain in. And I get plus or minus root 2 plus or minus root 6. So x equals minus root 6 minus root 2, root 2, root 6 are going to be the 4 intersection points. Okay, so these areas are identically the same. Write down definite integral that will represent the area. So the area equals 2 lots of the integrals from root 2 to root 6 top curve is h of x minus f of x dx. That's going to give me my 1 mark. I could have done negative root 6 to negative root 2. Find the total area is correct to 2 decimal places. If I go interactive, analysis, G-solve, integral from intersection, I'll accept the first one. I'll accept the second one. That area is that area, which is this area, which is this. And then times it by 2. That should be my total area, which is 2.72. To 2 decimal places, 2.72. I will confirm that it's correct. 2 keyboard integral from root 2 to root 6. Top curve is h, the transformed one. So my top curve is going to be this one. Copy, paste, minus bottom curve, and what I'm going to do is go to Math 1 and put in a bracket. Then you go to my original, which is this. Copy, paste, dx. Okay, answer by 2, decimalize it. I don't want to double it because I'd already put a 2 at the front, silly me. Same answer as I got before, 2.72. Okay, let D be the vertical distance between the two graphs of f and h. Find all values of x for which D is at most 2. So the vertical distance, so if I look from here, h is bigger than f. So I'm looking for h of x minus f of x to be less than 2. So I'm looking for this bit that was inside the integral, because that is h of x minus f of x. So let's copy that. Let's put this down here. Let's go paste. And I want that to be math 3 less than 2. And I'm going to select and solve for x. Didn't get a nice answer, did I? So how about I take this graph and I open up a graphing window and I go edit clear all, and I get the left hand side. There's the graph of the difference between them, and I want it to be less than 2. So there's 2. Okay, so I've also drawn negative 2 on because it's never bigger than 2 up here. It's always. So where is the negative 2? Because who's to say that f of x taken away from h of x doesn't give you a negative number? So if I consider the intersection points down here then, analysis, G-solve, intersection of the curve of the difference, I'll accept that one, and I want negative 2. So at this point here, which is negative 2.61, the difference is 2, then it's less than 2, less than 2, less than 2, less than 2, up until here when it's equal to, so coming across, that is negative 1.08. So, and when I jump across here, it's going to then be 1.08 x 2.61. Now, at most 2, so I include 2. So they're going to be the values of x where the distance between these two will not exceed 2. Is that the last question? It is.